Okay, quick video on how to find the roots in the quadratic function, given vertex form, standard form, or factored form. Okay, so let's just, forgot to put this one in, I guess. Okay, so remember when you're trying to find the roots, you could have two, you have one root, or you could actually have no roots. In all of these examples, I'm just doing ones that actually have roots, but yeah, you could have anything. So, vertex form. The easiest way, I think, to find the roots from vertex form would be to set y equal to 0, and then just isolate x. So work from the in. So first I'm going to get rid of that negative 18 by adding 18 to both sides. Next I want to get rid of that 2. It's being multiplied to the x plus 1. So I'm actually going to divide both sides by 2. So I end up with that. Next I'm going to square root because I want to get rid of that squared. I'm going to square root both sides. So those cancel out. And the square root of 9 turns out to be positive 3 equals x plus 1. Or negative 3 equals x plus 1. And if I isolate x, I get x equals 3 minus 1, 2. Or x equals negative 4. So 2 roots. Okay, if I want to find the roots from standard form, I could do quadratic formula, or I could do the factor, put it into factor form, whichever one you want. Actually going to factor it because I know it's a simple polynomial that multiplies to negative 12 and adds to negative 4. So x minus 6, x plus 2 works. And then I'm going to set each bracket equals 0 and solve for x. So 6 and negative 2 on the roots. And then finally, factored form, which is our easy. It's already factored. Set y equal to 0 and then just solve. So now I know x is equal to negative a half and x is equal to 5. So I got 2 roots there too. And just one more thing before we stop. We learned about something called the discriminant. And remember, the discriminant is just what's under the square root sign in your quadratic formula. So b squared minus 4ac. And the discriminant just helps us determine how many roots something has. So if you had an equation like the ones we just did, x squared minus 4x minus 12, we can sub those in for like a, b, and c, the coefficients, to determine how many roots our quadratic has. So in this case, if I subbed in negative 4 squared minus 4ac and calculated that, I would get 16 plus 48, 64. So I get a number that's positive. So right away I know it's going to have 2 roots, positive number. And then since it's actually a perfect square, like when I square root 64, I get 8. So I actually know it's going to be factorable. Awesome. So that's what the discriminant can tell you. So let's try another one. So let's say there was one like y equals, I don't know, I can't make one off the top of my head, but anyways, if you found the discriminant actually equal the negative value, you would know you have no root. And if it equals 0, you would know you have 1 root. So that's what the discriminant can do. It can help us determine the number of roots something has. And yeah, and maybe also determine if something's factorable, because if it has a nice square root, then we can probably factor it. Okay, awesome.